Okay, so here we're going to start off with two questions, and basically this is important because you need to be able to identify these things. Okay, so the first one says identify the constants in each of these expressions. And what is a constant in an expression? It is actually the number that does not have a variable. And remember what a variable means. The definition of a variable basically says that it is an unknown value. It could be any value. It could be 10, it could be negative 10, it could be a 10,000, it could be 1 million, it could be negative 30. It could be any possible number that you can think of, half, anything, right? So in this case, when we're talking about a constant, we mean that it is actually a number that we know for a certainty that it is just 5, or it is just 3, or it is just 2, because it is not multiplying with an unknown number, right? And in this case, in A, it says 3x squared plus 5 plus 6x minus 7y. And basically what that means is that 3x squared, there is an unknown, meaning it could be any possible number that you multiply with 3, and then you get some value. But with 5, you can see that it does not have a variable. Therefore, the constant, which the constant is an exact number that we know for a certainty, is just that value. It is 5, and then the next one here, try and identify it on your own. So in this case, it is 5, right? And then the next question here, it says identify the variables in each of these expressions, right? So in each of these expressions, you must identify the variables. Quite clearly, again, what are variables? It is alphabetical. It's alphabetical letters that signify any possible number that you could choose, right? So in this case, you actually have x squared, y to the power 3, z, and p, which are variables. And here as well, you have x to the power 5, x to the power 4, x to the power 3, x to the power 2. But now, what are they asking you here? They're not asking you what is the variable to the power, but they're just asking what are the variables. So it's x, y, and z and p. So here, what would be the variable there? Okay. So then we also have questions in algebraic expressions where you have to simplify the following expressions. So the ones that have been highlighted in red are examples that you'll see after this, right? So I do encourage you to try out the rest on your own, but generally, once we've done these examples, you'd have a very good idea of what to do. Okay, so the first one that we're taking on is A, and it says 4x on the bracket 3x plus 7 minus 8x times 2x minus 4 in the bracket, right? So what do you do to get the value for this? So what you do is you use the distribution method, or also known as a FOIL method, right? Where you would multiply 4x with 3x, and you'd multiply 4x as well with 7, right? So we would have 4x times 3x, that gives us 12x squared, and because it's x squared, meaning because we have one x multiplying with another one x, therefore it should give us an x to the power 2, right? And then, and you can also think of this when you say x times x gives us x squared, you can also think of it in the terms of exponents, right? And then we also have minus 8x, and then when we say minus 8x or negative 8x, then we multiply also with the sign, meaning that it's a negative 8x. So then you multiply it, and then you'll find that it's negative 16x squared, and you have inside the bracket that you have minus 4 times minus 8x, a minus and a minus multiplying each other, or a negative and a negative multiplying each other would give you a positive. Therefore, you would have 32x squared. And then what is the next step here? Now, in the next step here, then you have to identify basically the like terms. And the like terms in this case is 32x and 2x. And how to identify these like terms? You look at the variables. If the variables are exactly the same, not the constants, but the variables on their own, if the variables are exactly the same, then they are like terms, just as much as 12x squared and 16x squared. So basically, since it's 12x squared and minus 16x squared, then you'll give you minus 4x squared, and 28x plus 32x will give us 60x, and that would be your answer there. And then you'd see in this case here that you would multiply 4x squared y into 3xy minus 7x squared plus 8y squared minus 3x y squared, all into the bracket 12xy minus 8, right? So in this case, you actually find that when you multiply all these in together, you do not have like terms, because remember, the combination of the variables, being that it's x and y, are all different, because you can see here you have x to the power 3, x to the power 2, y to the power 2, but you do not find anything else that has x to the power 3 and y to the power 2 in the rest of the terms, right? And that's why we do not add them together. Therefore, this is the final answer once you've multiplied. Okay, and then the next one here, still the same procedure, and you follow it, and you would find that it is 39 x to the power 3y minus 17x squared y squared minus 7y to the power 3. Now again, if you find that you want to look at the question closely, please stop the video and then continue as you go along. Okay, and the next one, again, simplify the following expressions. But now these expressions are put in such a way that they are fractions, right? So here you would have to actually think and start using some factorization in some cases. So in the first one, where it's a, it's 15x to the power 3 plus 35y y to the power 2 minus 45x squared y. You find that in actual fact the common factor is 5x, because if you look at 5x and you multiply it in with all the other terms that you were given, or all the other terms that you had gotten, you would actually find that this would give you the same thing as this one when you simplify the top part. So once you've factorized it, you see that you have 5x outside the bracket and 5x at the bottom. So because 5x is at the top and the bottom, anything that, if you think of it, anything divided by itself is just 1. Therefore, you can just cancel them out. Okay, and then you're left with what is left in the brackets, which is 3x to the power 2 plus 7y squared minus 9xy, right? And then we have another one here where e says 16x squared minus 8x squared, all divided by 4x squared minus 1. But now the first thing you need to notice is that at the top you actually have like terms, because the variables are the same. It's x to the power 2 and x to the power 2. So you would say 16x squared minus 8x squared, and that will give you 8x squared. But now there is nothing more you can do with this, because you only have a single term at the top. You only have a single term at the top, and you have two terms at the bottom. These two terms cannot divide or simplify the term at the top, just like 5x divided by 5x at the top there. So in actual fact, the only time that you could have done anything is if it was opposite, where the 8x squared was the denominator and the 4x squared minus 1 was the numerator. Okay, and then we also see another one here that you apply some common factor factorization again, where the common factor is 8x squared, and then you are left with what's left in the bracket, and then you actually cancel out the two numbers, and then you find that it is 3x squared plus 2x minus 1, all divided by x. But since you have one term at the bottom, then you can actually divide x separately, individually, with all three of the other terms at the top. And so how would you do that? You'd say 3x squared divided by x, and 3x squared divided by x means that it cancels out one x, that leaves you with 3x. And then here it cancels out with x and x, it leaves you with 2. But then here it says it's minus 1, but it's divided by x, so it would be minus 1 over x. And you could have also realized that in actual fact 3x squared plus 2x minus 1 is actually a quadratic expression, and you would find the factors, and you'd say it's 3x minus 1, x plus 1 all over x, and that would have been your answer. Okay, and then another simplification. So with this one, it's more using square roots, and here you have c, where it says the square root of 5x squared y z to the power 3 all to the power 3 is square rooted by it's cube rooted, and basically what that means is that if we have a cube and there is an exponent to the power 3 as shown here, this actually cancels each other out, and then you're only left with what's inside. So what is inside here? It is only 5x squared y z to the power 3, right? And that would be your answer. And in this case, again, you have now 3x multiplying the square root of 9x to the power 4 plus 3x, or multiplying the cube root of negative 27x to the power 6, right? And in this case, then you can see that 9 is actually 3 to the power 2, therefore it's 3, and 4, it basically takes out two exponents from x to the power 2 and then your x squared, right? And then here again you have the cube root of minus 27, and minus 27 is actually 3 to the power 3, and then x to the power 6 is also 2, and then you're left with this, and then you'd actually find that at the final answer that it's equals to 0. Okay, and then you have these types of questions where they'll actually give you the value of a variable, right? As I had said at the beginning, a variable is something that we do not know, but when they tell you that the value of the variable is actually equals to negative 4, in this case it says a is equals to negative 4, b is equals to 1, and c is equals to 2 over 3, right? And then they say find the value of these expressions. So how would you do this? This just only means that now you know the value of a, right? So in actual fact, if we look at the first example here, where it's 3ab plus c, 3abc plus 1, then that means wherever a is, you would substitute minus 4, wherever b is, you would substitute 1, and wherever c is, you would substitute 2 over 3. And that's why we find that it is 3 times negative 4, 1, 2 over 3 plus 1, and that gives you negative 8 plus 1, that just final answer being negative 7. Okay, and then we move on to the last part of the video, and this is what we call solving for the unknown variable, right? And again, so solving for the unknown variable, the general idea about this is that whatever you do on the left hand side, you must do on the right hand side. An analogy or a way of thinking of it is that in actual fact, it's basically that if you had imagined if you're on a seesaw, right? If you're on a seesaw, if one person sits on one side of the seesaw would move up and it would not be balanced. But then if you put someone else on the other side and that person has the same weight as the person on the other side, then you'd find that it would balance, and you need to be able to balance it. So how do we do this? So the first one is 17 is equal to 4x plus 2. So the idea is that we need to find x, just x, not x to the power 2, not x to the power 3, not 4x. We are looking for x, right? So if we are looking for x, what can we do to get to x? So basically what we do is we can say, let's subtract on both sides. And why do we subtract on both sides? Because we want to actually balance the equation. So we would say we have plus 2, but then if we say minus 2 on the one side and minus 2 on the other side, because of the rule, the golden rule of equations, that you must, whatever you do on the left hand side, you must do on the right hand side, then you'd do it like that, and then you'd find that 17 minus 2 just gives us 15. And because it's 15 and you are only left with 4x, because plus 2 minus 2 just gives you 0, so basically this is all gone, then you'd only be left with 4x. Now remember again what I said, you're solving for just x, not x to the power 2 or 4x. You're solving for x exactly. So what do you need to do to get x? You divide the 4 so that these two can cancel each other out, so you'll be left with the x, and then you'll be left with and whatever you do on the left hand side, you must do on the right hand side. So we divided 4 here and we divided 4 there, and you will be left with 15 over 4 as your final answer. But there is an alternative way of doing this or looking at this, but it's still the same idea in the sense that if you had imagined that this particular equal sign is maybe like a river, this plus 4, so it's 4x plus 2. the plus 2 is on the one side of the river, and you could say that in this plus 2 is maybe like dry, and then the equal sign is the river. When you cross the river, it has to change its sign, right? Because if you think of it, if someone walks, he's dry on one side of the river, goes into the river, and then lands onto the other side, then that person has to be wet on the other side. So the idea is that you must do what is opposite. So opposite of that sign, right? Opposite of that sign when you're taking this one onto the other side. So that's what we did. So we said plus 2, it's actually the same as saying it's minus 2 on the other side, and that gives you 15. And then 17 minus 2 just gives you 15 over 4, right? And then you divide on both sides, and then you'd find that it is 15 divided by 4, and that's 15 over 4, which you could have also written as a mixed fraction of 3 over 4, right? And notice something here. The question was phrased that it's 17 is equals to 4x plus 2, but now we put it as 4x plus 2 is equals to 17. This is also acceptable because as long as you haven't done anything without balancing the equation properly, then it is still correct. Okay, and then we have the next example. So it's 7 times x minus 9 is equals to 10x, and so we would multiply in, and then when we multiply in, we find that 7x minus 63 is equals to 10x. So to cancel out that minus 63, we add by 63 on both sides, and then when we add by 63 on both sides, then we find that 63 is on that side, and this is cancels each other out. And then we want to take 10x onto the other side because it is a like term to 7x. It is a like term to 7x. Therefore, we need to take 10x onto the other side. And how would we do that? We can subtract on both sides by minus 10x and minus 10x, and then you'll be left with minus 3x, and then you divide by minus 3, and then you find that 63 divided by minus 3 will give you minus 21, right? And then there is the alternative way of looking at it, and so we move on. And then the final one is 1 over 3x plus 3 is equals to 3. And then in this case, you do the same thing. You subtract by 3 on the one side and the other side, so that you find that this cancels each other out. But also at the other side, you find that 3 minus 3 is 0. So then you only need to now get rid of the 1 over 3. So how can you get rid of the 1 over 3? You multiply by 3 on both sides, because 3 times 1 over 3 does give you 1. So it is x, and 3 times 0 gives you 0. And then we have the alternative way of looking at it. Other than that, I thank you for watching this video, and I do encourage you to try out the problems that I did not do in this video. Other than that, I'll see you next time.